There are three equations in trigonometry that are true for every single angle, not just the nice ones. They're called the trigonometric identities, and once you have them, you can simplify a monstrous-looking expression down to a single number, or prove that two sides of an equation are secretly the same. The best part, all three come from one theorem you already know, Pythagoras. Let's build them. First, what does identity even mean? An ordinary equation like x plus 2 equals 5 is true for one special value of x. An identity is true for all valid values of the angle. sin²A plus cosine²A equals 1 isn't true for one lucky angle. It's true for every angle you could plug in. That's the difference, and it's why identities are so powerful for proving things. Here's where they come from. Take a right triangle, right-angled at B with acute angle A. Pythagoras says AB squared plus BC squared equals AC squared. Now divide every single term by AC squared, the hypotenuse squared. The first term becomes adjacent over hypotenuse squared, that's cosine²A. The second becomes opposite over hypotenuse squared, that's sin²A, and the right side becomes 1. So sin²A plus cosine²A equals 1, our first identity straight out of Pythagoras. Now take the very same Pythagoras relation and divide every term by AB squared, the adjacent squared instead. The first term becomes 1. The second, opposite over adjacent squared, is tan²A. The right side, hypotenuse over adjacent squared, is sec²A. So 1 plus tan²A equals sec²A. Same theorem, different divisor, second identity. Divide the same relation one more time, now by BC squared, the opposite squared. The first term becomes cotangent²A, the second becomes 1, and the right side becomes cosecant²A. So 1 plus cotangent²A equals cosecant²A. Three identities, all from the single Pythagoras theorem. That's why they're so easy to remember. If you ever forget one, just redivide. In practice, you'll use these rearranged. From the first, sin²A equals 1 minus cosine²A, and cosine²A equals 1 minus sin²A. From the second, secant²A minus tangent²A equals 1. From the third, cosecant² minus cotangent²A equals 1. These difference forms are the ones that collapse big expressions instantly. Before we prove anything, here's the one strategy that rescues you when you're stuck on a proof. Convert everything to sine and cosine. Secant becomes 1 over cosine, tangent becomes sine over cosine, and so on. Once everything is in sine and cosine, you combine fractions and use sin² plus cosine² equals 1. 9 times out of 10, that's the whole trick. Let's warm up with an easy one. Evaluate 9 secant² minus 9 tangent²A. Factor out the 9. 9 times secant² minus tangent²A. But that bracket is exactly our second identity rearranged. It equals 1. So the whole thing is 9 times 1, which is 9. A scary expression gone in 2 steps. Now a proof. Show that secant A times 1 minus sine A times secant A plus tangent A equals 1. Convert to sine and cosine. Secant is 1 over cosine, and secant plus tangent is 1 over cosine plus sine over cosine, which is 1 plus sine A, all over cosine A. Multiply it out. You get 1 over cosine A times 1 minus sine A times 1 plus sine A over cosine A. The middle two brackets are 1 minus sine A times 1 plus sine A. That's 1 minus sin²A. So we have 1 minus sin²A over cosine²A. But 1 minus sin²A is cosine²A, so it's cosine² over cosine², which is 1. Proved. Notice the move that made that work. 1 minus sine. A times 1 plus sine A became 1 minus sin²A by the difference of squares pattern, and then the identity turned it into cosine². Spotting a 1 minus sign paired with a 1 plus sign, or secant plus tangent paired with secant minus tangent, is the single most common trick in these proofs. Train your eye for those pairs. One more pattern. Simplify 1 plus tangent²A times cosine²A. The bracket 1 plus tangent²A is secant²A by the second identity. That's 1 over cosine²A. Multiply by cosine²A and the cosines cancel, leaving exactly 1. Whenever you see 1 plus tangent squared or 1 plus cotangent squared, swap it for the single secant or cosecant squared. It almost always simplifies. 2 traps to avoid. It is sin² A plus cosine² A equals 1, never sine A plus cosine A equals 1. That's false. And pair the identities correctly. Secant² minus tangent² is 1, while cosecant² minus cotangent² is 1. Don't cross the second with the cotangent. Keep the families together. Your turn. The question's on screen. Pause if you like, but try it first. 10 seconds. Go. Use the rearranged first identity. 1 minus cosine²A is by sin² plus cosine² equals 1, exactly sin²A. So the expression equals sin²A. That's option A. Lock it in. 3 identities, all from Pythagoras. Sin² plus cosine² equals 1. 1 plus tangent² equals sec². 1 plus cotangent² equals cosec². When a proof fights back, convert everything to sine and cosine and hunt for difference of squares pairs. Last challenge, it's on the screen. Don't say it aloud. Type your answer in the comments and I'll pin the right one. And that completes Introduction to Trigonometry, the ratios, the standard angles, and the 3 identities that tie it all together. Free notes with 60 practice questions are in the description. Subscribe for the next chapter, Applications of Trigonometry, where we finally measure those heights and distances. This is Clarix. Keep going.